Hi there, it's exercise 3b, looking at the modulus sign. We saw the modulus sign at the start of the year, and then we had questions like this. Might have been, say, 2x plus 5 modulus, and we either solved inequalities or equations. So if I make up one now, equals 17. So one thing you should remember, that the modulus sign could be positive or negative. So therefore we had to allow for the fact that 2x plus 5 could equal minus 17. Or it could be a second solution that 2x plus 5 is equal to 17 after all. That's the thing, you don't know what it was originally. So this really, I'm only showing you this. What's minus 5? That equals minus 22 when I move it over. Therefore x is minus 11. Or the alternative is that plus 5 moves over, 2x equals 12, and therefore x equals 6. So I'm showing you this just to remind you that the modular signs means it could have been positive or negative. And we're going to draw graphs in this session. A little reminder again, we did look at a variety of ways of writing inequalities using set notation. So here, for instance, x belongs to a comma b. X is between a and b. But notice it can't be equal because there's no equality here, and therefore we have curly brackets. Whereas when we can be equal, here and here, x is between a and b, but can be equal to either, notice we have square brackets. And you can have a mixture of square and curly depending on how the inequalities are. You also need to be able to write things like x is greater than or equal to 4, because it's not so obvious as to what two numbers is between. And this is where we write something like x belongs to the interval, and we write 4 comma infinity. Notice infinity, you can't really be equal to infinity, so we have a curly bracket. But in this example it says x can be equal to 4. And so all of these are really like that. The very bottom one I'll explain. X is less than 1 or it's more than or equal to 4. So we write that in terms of the x is less than 1, we say it's between minus infinity and 1. And that's okay, that's reasonable. It's a bit like this example we've got up here. Or, now this is the symbol for or, which you may remember, it's actually the union of in set notation. So or x is between 4 and infinity, so square bracket for the 4 and going up to infinity, curly bracket. So I've got a few of those for you to have a practice with. Have a look at those, see if you can get some answers for me, and writing those in this set notation kind of way. Or interval notation is the alternative way of describing it. So we're going to go on, we're going to look at now the modulus function, and I suppose what I want to just highlight is the way we write this. The modulus of f of x is written with the modulus sign either side of it. Interestingly, you can, for instance, write this. You could have y equals some function. It could be like you might be doing 4 lots of x squared, but you want the 4 lots of modulus of x squared plus 6, say. That is an alternative. So what I'm initially doing is I'm looking at an example, say, where y equals 4x squared plus 6, and I find the modulus of it. So here I'm doing the modulus of all of it, whereas here I'm only looking at just the modulus of the x, the little inner bit. So just be aware of that there are two versions of this. Either way, if you see these two lines, it means the modulus of x. And sometimes written the absolute value of x, and certainly on graphical calculators, you often see a function on a graphical calculator which says abs, and abs is an alternative way of doing or writing the modulus sign. But if we was doing this in the exam, we must write the modulus sign. I've got an example or two for you here. The modulus of 4 is 4. That's because if it's positive, it just doesn't do anything at all, this modulus function. But if it's negative, it changes the sign. It makes it positive. So that's what I want you to be aware of. The modulus function will change the sign. If it's negative. If it's positive, it stays the same. So I want to look at a graph. It says, effectively, I want the graph of mod x. And the way to do this is to know what the graph of y equals x looks like. And you should know that y equals x is essentially a straight line through the origin with a perfect gradient of 1, straight through, perfect diagonal. So when I do y equals mod x, the way to think about this is, well, the positive numbers won't change, so 2 will be 2 still. So if I draw y equals mod x, it won't change it. But what will happen is the negatives will change. And normally this line will come down here. It wasn't exactly my best graph ever, you get the idea. And it will actually look like that. Now again, if I want to draw the graph of mod x, this stuff at the bottom will reflect up. Essentially anything negative, a value there say of -3, will become a value of 3 there. So if I draw that, that is the proper graph, and now it does actually say y equals mod x. So just be aware of that. We describe this as a reflection in the x-axis. Anything below the axis becomes positive. It reflects up there. So we get this reflection taking place going up there. And domain-wise, any number can go into it because, you know, even if it's -4, it still chuck it into it because it will ignore the answer you would have got if it's a negative. And here it was a -4 that we got out of the function, but we just pretended it was 4. The range, of course, is not the same because this reflection means you can never go underneath the 0 line. So the range of this is y is greater than or equal to 0. Some graphs are harder, so I'm going to try to do this, but be aware that you may find that this is a lot easier next year when you do it on a graphical calculator. This means graphical display calculator. So when you get lent one of these next year, you'll probably find this is okay. But for the first instance, let's just draw two parts of this. It says y equals x minus 2. X minus 2 actually does this. That's the graph of y equals x minus 2. Now it says mod it. Find the modulus of it. So that basically means it's going to go, well, and then when it hits that axis, it will reflect back again. So at 2, this is now the graph of y equals mod x minus 2. And it also wants me to then add on this one, so it might be worth my while drawing this graph. Now this is the next graph, y equals x graph, but plus 1. So y equals x plus 1 does that. But now this stuff at the bottom gets reflected up. There you go. So hopefully you can draw it a bit better than me. That crosses at -1. So if I was to try to draw these two graphs together, obviously this bit, add this bit, makes it go higher. This bit here, add this bit here, makes it go higher. Then what happens in between? If I just show you this graph, you'll notice actually, because they're both saying x and x, as this graph goes down here, this graph here actually at some point starts going up. So in between 2 and -1, you get this weird thing that it goes straight across. So I think there are a couple of those it wants you to draw, and I wouldn't worry too much about it if you find it a bit hard, because as I say, probably in a year's time you'll have the graphical calculator and make it a lot easier. The ones I do want you to be aware of are these graphs. So f of x equals x minus 1, and I want us to draw y equals f of x modded. Now first of all I'm going to draw the graph of, I'll draw it up here. This is the graph of y equals x minus 1. And y equals x minus 1, it just looks like that. It hits at -1, it's got a perfect diagonal, y equals x minus 1. Now bear that in mind in terms of what I'm about to do. If I mod it, this is what I was just playing around with. What will happen is wherever it goes, does that, hits at 1, same as this does, my graph. That's meant to hit at 1. But whenever it hits that graph, it bounces back. So let's see if I can get there, something like that. And so this bit down here bounces back. And this is the graph of y equals the mod of x minus 1. And as you can see, it's written as mod of f of x, because that's what f of x is. What happens, though, if I do the function with a mod x? Now, the function with a mod x is actually got, that was my y equals x. And really I'm saying I want to draw mod x minus 1. Now that changes things, because really it's saying, well, this graph now which I started with isn't right. I now need to know the graph of just y equals x, which is this bit here, and then I will bounce it back like that. But then it says, don't forget to take away 1 at the end. So rather than bouncing back there, it will bounce back there. No, not my straightest line in the world, I think you'd probably agree. And it'll hit at -1 there. So what that appears to have done is it appears that it looks at the right hand side of the graph and it just goes, well, I'm going to ignore the left hand side, all that bit goes, and I'll just reflect it over there. And that's the way we think about it. We think of it as being a reflection again, but it reflects everything on the right over to the left as well. And so that's what the two posh graphs versions look like. So think about that. I'll do another one here. Now this one is one that's been drawn for us. It's y equals f of x, and it says draw y equals the mod of f of x. Well, we know anything underneath the line, when we do this, is a reflection in the x-axis. So anything underneath the line will bounce upwards. Everything else will stay where it is. So this stuff here is the bit that's got to go. I'm just trying to get my head around which way it's going to go. Well, there it hits at -2. I think it does something like that. So if I try to draw that properly, it's not easy on this tablet, something like that. And all the stuff at the bottom, that's gone. That's not going to be there anymore. So this is y equals the mod of f of x. Notice what happens if I put the mod around the x but not the f. And basically, as I said to you, this is still a reflection, but whereas this last one was a reflection upwards, this is a reflection left. Anything on the right goes to the left. There it is, because this bit was on the right, so it reflects over to the left. But everything else on the left disappears. And that's what I want you to know. So how is the graph of fx changed to get the graph of f of x? Well, you reflect the portion on the below the x-axis and erase it. So anything below the x-axis goes up to the top. And what if you do this second type of graph? Here you erase the portion on the left and reflect the bit on the right over to the left. One last example of this, just to show you y equals x cubed minus 2. Ooh, slightly dodgy axes. It looks like that. Now if I x cubed minus 2 like this, all this bit underneath has got to bounce back. So it goes like this, hits, and then I think it does something like this. It bounces. So this bit underneath reflects upwards. So it goes upwards. Whereas this one, when I put the mod cubed, this is, I suppose, the equivalent of y equals f of mod x minus 2 like that. Whereas this is y equals f of x, all modded. Anyway, what's it do? Well, my graph initially looked like that on the right hand side, so I'll just reflect it over there. That's what you've got to do. So slightly different question. This is an exam question, a bit easier, I think. It says give details of two transformations needed to make y equals mod x. Now we know mod x now looks like that. How do I make it look like that? And it's got a, looks to me like it's got a stretch scale factor of well, it's not so much in the brackets, but we've got to be a bit careful, I suppose. And this is then is a translation. Now these are the answers because we're running out of time. So you remember last time I said to you, if it's in the brackets, and I suppose we've got to think of this as a bracket, even though it's not a bracket. It's like it's a function within a bracket. So bodmus or bidmus does not apply here. But bidmus even. You basically have to do it in the wrong order. So you'll notice it says it's a translation first. And it says +3, so it's going -3. So it's going 3 to the left. And then it says times by 2. And again, I suppose, because it's out of that bracket, they've talked about it a scale factor of 2 in the y direction. Well, anyway, have a look at that if you can. Exercise 3b, it says exercise questions 1 and 2. I can't remember how many questions there are. You'll have to have a look. But best of luck and see how you get on.